Shear, a second important factor to be considered when determining the strength of beams. An internal shear force V generally is present and in some cases may govern the design of beams. Many materials such as wood are primarily weak in shear. For this reason, the load that can be supported may depend on the ability of the material to resist shearing forces. Beams are normally horizontal. Cross-sections upon which bending stresses are investigated are vertical. These shearing stresses in beams are generally referred to as vertical or transverse and horizontal or longitudinal. Transverse shear action is a pure shearing condition and occurs even when there is no bending of the beam. However, beams do bend, and when they do, fibers on one side of the neutral axis is placed in compression and those on the other side are placed in tension. In effect, the fibers on either side of the neutral surface tend to slip in directions opposite to one another. Longitudinal or horizontal. The existence of horizontal or longitudinal shearing stresses in a bent beam can readily be visualized by bending a deck of cards. The sliding of one surface over another, which is plainly visible, is a shearing action that, if prevented, will set up horizontal shearing stresses on those surfaces.
Relationship between transverse and longitudinal shearing stress. This section will now show that at any point in a deflected beam, the vertical and horizontal shearing stresses are equal. Therefore, the shear V diagram is a representation of both transverse and longitudinal shear along the beam. Consider a simply supported beam as shown. V is equal to the summation of FV times area, where FV is equal to the unit shearing stress and A is equal to the cross-sectional area of the beam. Removing the small elemental square from the beam, we draw an FBD showing the forces acting on it. As shown on figure 8.17, assume that delta y is equal to delta x, and that the elemental square is very small. FV is equal to transverse shear stress. For equilibrium vertically, we arrive with this formula. To place the elemental square in rotational equilibrium, sum moments about point O. Summation of moments at point O is equal to 0. FV1 times delta x is equal to FV3 times delta y. But delta x is equal to delta y. Therefore, FV1 is equal to FV2, equal to FV3, and equal to FV4. Shears FV3 and FV4 form a counterclockwise couple. From the preceding example, we can conclude that F transverse is equal to F longitudinal at a given point along the beam length.
Development of the general shear stress equation. To arrive at a relationship for the shearing stress, consider the beam shown. At the section A to A, the moment is MA. And at section B to B, an incremental distance to the right, the moment is MB. From the moment diagram, we see that MB is greater than MA. On the figure 8.19, bending stress on a beam section, letter A, beam section between sections A and B. Letter B, bending stresses on the beam section A to B. Therefore, FCA is less than FCB, and FTA is less than FTB.
In figure 8.20, for FPD of the upper portion of the beam between sections A and B, therefore, FCA is less than FCB and FTA is less than FTB.
Substituting MB minus MA into the earlier equation, V longitudinal is equal to Q over I times VT delta X, where
VL is shear force acting on the longitudinal beam surface or area is equal to V delta X. FV is shear stress longitudinal is equal to V over shear area. FB is equal to V over V delta X. FB is equal to Q times VT delta X over IB delta X. FB is equal to VQ over IB, where FB is equal to unit shearing stress transverse or longitudinal. V is shear in the beam at a given point along the beam length, usually contained from the shear diagram. Q is AY or the first moment. A is area above or below the level at which the shear stress is desired. Y distance from the beam cross sections. NA to the centroid of the area above or below the desired plane where shear stress is being examined. IX moment of inertia of the entire beam cross section. B is width of the beam of the plane where the shear stress is being examined.